For our equilibrium example, I chose probably my least favorite equilibrium question of all time because it's a really good focus on explanations. So once again, when we see a question, we're kind of giving ourselves a quick overview. Okay, reaction, reversible K value. All right, it's equilibrium. I have volumes and molarities. Asks with K, get to your concentration. It's diluted, greater than, equal to, or less than, justify. So when we're looking at our overall test and examples, we're thinking, am I ready to go with some equilibrium calculations and or explanations, or do I want to focus elsewhere? Obviously, right here, we're doing this question. So when I look at this, I see specific values that I'll be ready to come back to, but considering K, determine the concentration. Awesome. Look at K, molarity with volume, volume with molarity, total volume, justify. One thing that I notice here is it's asking me to determine and justify, not to calculate and show my work or support with the calculation, which is a little bit unique. I know what that means, which is why I chose this question. But if it's saying justify, explain, but it doesn't say justify with the calculation, then maybe it's something that you can connect numbers, but not necessarily do math to prove. So I look back at my K and it's huge, 77 million. 77 million for a K means that this is not just a little bit higher, or my product is not just a little bit higher than my reactants, but it's way, way higher than my reactants. So that means in this case, we could try to do a Rice table, but our math would get kind of sloppy on that. Or we can realize that is my clue that we're going more or less totally to products. So justify my answer, well, all of the barium and all of the EDTA are going to combine to make this. So that would be part of my justification. So then I'd think, well, it's limiting excess, 0.2 molar, 0.3 molar. So this is what will run out first, 0.2 molar of 50 milliliters. The important thing here is once I've mixed these, even though I had 0.2 moles per liter in my 500, once it's mixed, it's watered down and becomes 0.1 molar barium, 0.15 molar EDTA. So the product will run out, or excuse me, my reactants will run out when I make 0.1 molar product, or the technical term for it, I believe, is the chelated barium ion, or the complex barium ion. So we would think about that. It goes to completion. The thing that I have less of runs out first, but always, and this is true if we're talking about solubility or anything, it can come up in thermo and other places, this volume plus this volume makes the total volume. Our ion concentrations are therefore halved in that solution. It's diluted with distilled water to this. After equilibrium has been reestablished, is it greater, less than, or equal? This, being a 4-point question from back in the day, lets me know that I'm going to get a point just for guessing greater than, less than, or equal to if I get it right, even without justification. We may not know that to be true this year, but even if you aren't sure on something, if you see that you're asked greater than, less than, or equal to, guess, try to justify, try to get full points, but that can sometimes be a place where you'll get a point. So the moles of barium, I water it down, I'm diluting it. This, when you look at the rubric, is another reason it's not my favorite, is you can guess and then your justification can be really short. That's kind of a memorization of a fact, but it is something we could put on an equilibrium sheet. In a diluted solution, the ions actually become more favored, or the percent ionization increases the more water we put in there. We can mathematically prove that, but the way I kind of think of it or can justify it in a way that I can remember it is it's kind of like with gases. When we increase the volume, it shifts to the side that has more moles of gas. Here I'm increasing my volume. I'm going to shift towards the ionized side, or the side that's going to be more spread out. They are more free to move around. On the answers, so I've got the rubric here. The way that they prove it mathematically is thinking about, well, if I make this 1/10 as much on the top and I make each thing 1/10 as much on the bottom, overall, my K, the 1/10 over 1/10, cancels, but I still have a 1/10 on the bottom, or my K becomes, or excuse me, not my K, my new ratio becomes 10 times bigger because, and look at the rubric and it'll make more sense, but there's two things here that are being watered down as opposed to just one. So the shift in order to get back to the correct ratio or to get your Q back to being K, we have to increase the concentrations of these a little bit or it will be shifting left. So that's a weird Le Chatelier's principle thing. But when I am changing volume, when I am changing pressure, when I am adding or removing something, it does shift, but it shifts to get back to the same ratio. So in this case, watering it down caused all of my molarities to change. And it had to shift so that the new molarities ended up with the same ratio of products to reactants. So even though we said it went to completion before, now we're back in this weird equilibrium scenario where it's kind of going to completion, but it's less to completion. Or it's the same degree to completion, I guess, but in that degree of completion, we do have a slightly higher ionization. So a whole mess here, but it's a great example of how you can use numbers in justifications and how we can have an equilibrium where we don't have to do any calculations while justifying completely. So definitely check out the answers in the student samples on this one. This is a good kind of in-depth one to try to wrap your mind around a little bit.